sweet.
And then did I tell you S was 0.410? And then the area under it that wasn't colored in at all, 0.486.
I wrote 0.476. I don't know.
Hmm.
I don't know if I just wrote it wrong.
Maybe I wrote it wrong. You know that happens. You've seen it happen.
That makes me like want to cry.
Well, here's what I like about it. You know how like usually it's like, here, let's do some math. And it's like,
Explain.
here, let me give you a whole page of explanation before we even try to do some math. All right, so a solid of revolution. We've done this because I think I made you do some of these in geometry with like cylinders. Like if you had this line and we spun it around, what would be the volume of that cylinder? And we did this a little bit in geometry. Had a tub of sand with a stick in the middle of it, and you slid a piece of plastic down that stick and spun it around. You just took a flat object, and when you spin it, you've turned it into like this three-dimensional figure, right? Well, that's kind of what's happening here. A two-dimensional shape is rotated around an axis. So you've got this lovely piece of a parabola right here, okay? And if you spin it around the x-axis, you're going to get this shape right here, this solid shape.
I'm getting flashbacks to 3ds Max. Can't really.
Me either, actually. Okay, now imagine slicing that particular solid into individual discs, like round, circular.
Like
Yeah.
chopping it up.
Like I'm cutting it.
Yeah. Okay.
Yeah, okay. The volume, if it had a height of 1, the volume of those would be pi r squared, because its volume is pi r squared h. But if we make sure that the height is 1, then it's just pi r squared, right? So the sum of all those discs would be, yeah, discuses, would be the definite integral from a to b, from here to here, of pi times f of x minus the axis of rotation squared. Because this f of x minus the axis of rotation would be from here to here, which is what? What is that? From here out, or that's the radius. So this is your radius. So it's pi times the radius squared dx. That would be the sum of all the discs. And if you get the sum of all the discs, then you have the volume of the solid.
Spell radius, right?
Radius. Yeah, I didn't get.
Okay. I was like, radius.
Yeah. All right. So notice that the axis of rotation is the x-axis, and it's what we would call, the bottom function if we were looking for that. Okay. It's also the x-axis. Imagine for a moment what the solid would look like if the axis of rotation were still the x-axis, but the bottom of the function was the line y equals c. So what if I still went around the x-axis? The bottom of the function is here, and I went around here, and then around here. Yeah, it'd have a hole in it, right? So it would be the same shape, but it would have this cylinder, empty cylinder in the middle. Okay, if that's the case, your radius, you've got to find your outer function, but you've got to subtract the inner function, because you've got, you took a hole out. You've got to subtract it out. The outer function is defined as the function that is farther from the axis of rotation. And the inner function is the one that is closer to the axis of rotation. So like this one, this volume would be pi times the integral from a to b of f of x minus 0 squared minus, this is c minus 0 squared dx. What a day to miss. Gonna flip this over.
So if you were to rotate like a parabola, that's like, would that like make a sphere?
No, it'd be like a double-ended one of those things that we just saw, but it'd be wider. It'd be the
You
same
mean
size
an
on both.
upside down parabola?
Yeah. Like,
No.
No,
Depends on what axis.
the x-axis.
It'd just be the same kind of.
It would
thing.
have to be, if it's going to be a sphere, this would have to be the same as this.
Yeah, like if it's even,
All of these would have to be the same. Well, that's not gonna be a parabola. What's that gonna be?
A circle.
A semicircle,
Yeah, semicircle circle.
right?
but that would like you. rotate
That would
and
make a sphere right there.
Okay.
That would. Okay, this is a big if. If the axis of rotation is the x-axis or parallel to the x-axis. So we've been given that if. If it's that, which means we can deduce that there will be problems that are not rotated around the x-axis or a line parallel to the x-axis. But if it's rotated around the x-axis or a line parallel to the x-axis, then the integrand needs to be in terms of x. And the limits of that integration have to be the x values of the point of intersection. So like here and here. So let's look at this. We've got y equals x squared and y equals x plus 2. We want to find the volume of the solid that's formed when we rotate this around the x-axis. Okay, so volume is going to equal pi times the integral from -1 to 2. Where did I get -1 to 2?
Or that.
Yeah, those are your x values of your points of intersection. X plus 2 minus 0. That's f of x. That's my top function. Squared minus x squared minus 0 squared dx. Okay, so that means this is going to be x squared plus 4x plus 4 minus x to the 4th dx. All right, so that becomes x to the 3rd over 3 plus 2x squared plus 4x minus x to the 5th over x. No, over 5, not x. That would be a complete nightmare. From -1 to 2.
And this isn't a complete.
That would be even worse. right, so here we go. That's gonna be 8/3 plus 2 times 8, right? Because force, this is supposed to be 8 plus 8. So that's 16. Okay, minus 32/5 minus, I don't think I'm having enough room.
Where'd
That's
the
a,
pie go?
oh, it's tiny right there. You just didn't see it?
Okay.
Because you have your glasses off.
Yeah.
See, that's it. Minus a negative 1/5, 1/3. Dang it. Okay. Plus 2 minus 4 plus 1/5. I probably should not try to do all that fraction stuff in my head because it's pretty obvious I can't do arithmetic today.
It's next.
All right, I didn't even get the right answer in the calculator. Let me try it again. Let me do it piece by piece.
So you need to take a nap.
Dude, we had softball really late last night, and poor Katie Beth was just beside herself last night. Or this morning, because she stayed out too late last night playing ball. Okay, I think that I got the wrong answer last year, and no one stopped me. Don't stop me now. Oh, I see what I did. Okay, so that's what I did last year. I combined all that. And then, so that's why it's not matching up. Okay, we're good. We're good. We're good. We're good. We're good. I think. So I think that this is 184/15. And then this is, I'm not there yet. Plus 32/15. Yeah, okay, we're good. So the answer is 72/5 pi. That's my volume.
Now you get this on.
You're welcome. And it's like an earworm. You're not gonna get it out of there. Okay. So apparently the hardest part is the fractions. And remember to put pi. I mean, that wasn't too bad, right? You do your top function minus your bottom function, kind of simplified it, and then took the antiderivative, substituted in, tried to put all that in my calculator at once, did not work out for me. So I did this side and then this side, and then I got an answer. Okay, now let's change it up a little bit. Find the volume when the region is rotated around the line y equals 4. Okay, so we're not going to subtract 0 this time. Okay, because we're going around y equals 4 right here. If I rotate around y equals 4, what's my outside function this time?
What is the outside one? The farthest away?
Mm-hmm.
It's x squared.
It's x squared, right? It's the one furthest away. So the volume this time is going to be pi, I remembered pi that time, from -1 to 2. x squared minus 4 squared minus x plus 2 minus 4 squared dx. So that's going to be like x to the 4th minus 8x squared plus 16, right? Minus. Okay, so let's just go ahead and change that to x minus 2 squared. So that's going to be x squared minus 4x plus 4. Or x to the 4th minus 9x squared plus 4x plus 12. I went back to algebra 1 where you check off everything you've done because I feel like that's where I am mathematically today. I feel like I'm at an algebra 1 level right now.
No wonder I didn't do well at that.
Yeah.
I did okay in the past.
All right. Okay, so now let's take the antiderivative. Okay. Dx anymore, 'cause I just did it. Check my antiderivative against your antiderivative. Don't check yours on mine. You'll see if mine's right. If we all concur, let's move on. So that's going to be pi times. All right, so that's going to be 32 over 5 minus 24
Where are these numbers coming from that we're plugging in?
here.
She's plugging in the.
Oh, the,
rest of
okay, okay.
section.
Yeah.
I was just, okay.
Okay, so that's 4. That's 8 and 24 minus negative 1/5 plus 3 plus 2 minus 12. All right, I'm going to do this side and then that side again. I'm not trying to put that all in my calculator at once again. That's I got 108 over 5 pi for my volume. Okay. We'll go ahead and try this one. So let's go back. Now we're going over the line y equals negative 2. 1 over the line, y equals -2. So what's that one going to look like in the setup?
So it's gonna be like,
Your line is gonna be your outer function.
yeah, so it's like x plus 2 squared. The first part,
Okay.
and then minus
All right.
x squared plus 2 squared.
I think you're going to see something about that. We're going to work through it and then we're going to talk about it. So you've got x plus 2 squared minus x squared plus 2 squared dx. Okay. So that's x plus 4. So let's just know that that's that should be 8x, not 4x. Yeah, there we go. And that should be 16, not 4. So that's going to end up being 12. Okay.
Will not be a parade tomorrow.
What?
Mine's just sitting there.
Okay. I messed this up so bad. I need to.
Yeah, I was supposed to, is that not x to the 4th plus 4x squared?
Yeah. It is. That should be a 4. And that should be that should be a 4. And that should be plus 4x squared. Yeah. But it's not plus, it's minus, isn't it?
Yeah.
Okay, one more time. X squared plus 8x plus 16, x to the 4, 4x squared plus 4. So it's going to be minus, okay. Okay, I'm going to leave it like that for right now. All right. Okay, I'm going to leave it like that. All right, go ahead. You finish it. I obviously have no idea what I'm doing right now. Finish it. Don't trust me. Check my work.
Is that not supposed to be minus 3x squared?
Where?
Is it x squared minus 4x squared?
Yes.
I'm gonna still like the first part of it. I'm not.
Let me do it in a calculator. Just make sure.
Pretty sure this is right now.
Yeah, I'm done. Yeah, that's right. Okay.
We messed up as much as we possibly could.
Yeah.
Honestly, yeah.
So that's going to be x to the 5th over 5. That's going to be x to the 3rd. 4x squared plus 12x.
right.
You definitely have to do the math because I'm not doing that math. Try. It's not gonna work.
Secretly, she's just doing this on purpose so she doesn't have to do math.
That's it right there. It's making my eye twitch. Math is supposed to be the easy part. Not for me.
Is it 162 over 5
Pi.
pi? Yeah.
Yes, it is 162 over 5 pi. Yay.
Just put it in a calculator.
Apparently I can't even do that right today.
I didn't substitute it in. I just put it in the calculator as the integral.
Oh, okay. It's because my twitchy eye.
I mean, I know to do that.
Axis of rotation is the y-axis or is parallel to the y-axis, then your integrand has to be in terms of y.
What?
And the limits have to be the y values of the points. Yeah. Mason, did you just grunt? Okay. Okay, just checking.
It's the same thing, but it's just kind of.
Yeah, well, it has to be in terms, if it has to be in terms of y, like this would have to turn into y squared equals x. And this would be y plus 2 equals x. So it's going to be like that.
That makes sense. So far.
So far, so good. So your volume still going to be pi times. All right, so this goes from -1 to 2 if you're looking at your y.
I'm so gonna get this mixed up at some point.
Yeah, you will.
Like, there's no.
It's
sugar on
okay.
it, you
It's
will.
totally expected. I promise. All right. So this is just going around the y-axis. So the one that's furthest away is the line. The line is now y plus 2. Minus 0 squared minus y squared minus 0 squared dy. Now I feel like I'm remembering something about if you accidentally put dx, you will lose a point on a free response. I know we talk about like, oh, they don't tick off for spelling, blah, blah, blah. But that's like a huge difference, okay? That's a huge difference. But the rest of it's the same. So it's pi from -1 to 2, y squared plus 4y plus 4 minus y to the 4th dy.
Yeah, I'm like,
Yeah, it's not any different at all. The rest is exactly the same.
it kind of feels
But this looks kind of scary. This is what I got, so you can check it. We're gonna skip down to this one next. Ugh. All right, let's skip down here. We're gonna go around the line. X equals 7, so that's like way out here somewhere. 7. what's my furthest function on this?
That's the parabola.
Okay. So that's y squared minus 7 squared minus my inside, which is y plus 2 minus 7 squared dy. And then from here, it's no different. It's the same that we've been doing. So, if you want, you can work through it,
So
or you
if
can
you had
start
a
on homework.
question, I have a question. If you had a question like this
Uh-huh.
on a calculator, could you put just that in and you would get an answer?
If you use all your parentheses correctly,
You could get an answer.
you could get an answer from that.
So if it, are they gonna give us problems with like E and stuff in it for that, or is it just gonna be?
If
kinda
you
like-
had that, that would not be a calculator question.
Right,
You
I knew
could-
that.
Yeah,
wouldn't be.
yeah, but if you had, like an E, or if there was something that you then had to turn around and use for something else,
yeah.
then you might have a calculator. But if it's just that, that's gonna be a
Yeah.
non-calculator. Yeah. So again, you can finish this one. I'll give you the answer. It's 243 over 5 pi. Or you can start on your homework so y'all can work on it together. So you've got 5 problems. Just kidding. It's like 1, 2, 3, 4, 5,
4 or 5.
4, 5, and then 2 free responses.